Well, happy Wednesday. We made it. Um, I think we're doing pretty good. We got a little bit ahead, which is good. When we talk briefly on branching today, we'll have everything you need for Project Zero. Was the goal. So we can start that one today. We'll be doing 2 weeks on the 24th. I think that should work out pretty well for us here. Um, so I'm not going to move ahead the due date for Zybooks. So branching will still be the following week, right? So all this stuff um, in the assignment section, chapters 1, 2, and 3 are due next Monday, 11:59 p.m. Again, this is your points for reading your book. It actually is very helpful here. There's a lot of good stuff, good content in here, and then lots of practice. So looks like not very many of the Xylabs have been done yet. That's okay. It's not the end of the world. But I do need to warn you, they take some time. Right? It's not, this is a 2 minute click and you're done exercise. These take some time. Uh, well, that's okay, right? This is a 4 credit class, so the expectation here is about 4 hours. I know we have a lab and counting hours is a little bit weird, but about 4 hours in person. And then for every credit, you should have about 2 hours outside of class worth of work. So it's about a 12-hour a week commitment here for one class. And, this being the third week, we're about, by the end of this week, about 36 hours in. So if you're just keeping track, on the back of a piece of paper somewhere, this is about 36 hours worth of effort by the end of this week. So definitely doable here. If it's taking you more than a couple hours to get these labs done, let me know. But taking a couple hours to get the labs done is okay. That's about where it should be here to make sure you get enough practice getting these in here. So um, did I ask on Monday? I forget who I asked when. My apologies. If you folks have any hobbies that you're good at, you do like sports or play instruments or okay. I forget who I asked what. So do you do any sports or play instruments or have other hobbies that you're good at? Like competitive video games or anything? Yeah. How'd you get good at it? Practice. Yeah, and ideally you're here because this is probably going to be your major, right? Do we? I guess we didn't even do introductions. I'm so messed up because of that, like a half week and a half week. Um, yeah, I had to leave early. That's right for my appointment. So occasionally we get people who aren't data science majors here in this course. Anybody not a data science major? Okay, so if that's what your major is going to be, you probably want to be good at that, right? Sometimes we get math majors who take this course. Sometimes we get stats people. I think I had one person who's healthcare informatics or something. But if you want to be good at it, you need to practice, right? I told a dumb story to an earlier class, and they all laughed at me here. But football, not American football, but soccer, right? Football, the actual football, like the rest of the world calls it here. Um, there's a guy who got rather famous for the way he kicked the ball and make it bend. I think his name was Beckham, and he would bend it like Beckham. Is that just something old people say? Okay. I was like, oh, that looks really easy, right? He does like a kick off the corner and it goes into the goal somehow, like taking an arc. And it's just physics, right? We can understand physics and get a nice spin on the ball, and obviously the air makes it curve. And I was like, I can do that. No, I can't do that. It does not work for me, but I haven't practiced. So put your time in, you'll get there, which is great. Um, now, I had a conversation with some seniors one time. I used to have my office in the game lab, which was cool because I'd hang out and work on their projects and stuff. Um, and they were chatting like, what advice would you give to freshmen or people, just starting off, taking 150, 1501 here. And their advice made me a little bit sad. They're like, if that class is hard, quit. It's like, well, what do you mean quit? Like that, isn't that bad advice? Like, shouldn't you just try harder? They're like, no, classes only get harder. If you're struggling through this one here and this is your major, you're going to be miserable for 4 years. Like, oh, okay, I guess that sort of makes sense for advice. But um, I'd still like to believe anyone can pass the class. It's just going to take some time, energy, and effort. Right? I'm available to help. That's sort of why I think they pay me to teach, is not to give you amazing lectures or anything, but to help you. Right? Learning is very much an individual sport. Right? I can give you information, but I can't make you learn it. Right? If you want to learn it, that's on you. Right? I'm here to help. I'd like to imagine that's my job, and I get paid to help you learn. I happen to demonstrate a bunch of things, so you'll see it my way, you'll see it the book's way. Um, there's tons of good resources online. I can show you Dr. Chuck's website. He's out of the School of Information in Ann Arbor. He has a whole free ebook and YouTube series that goes along with it of learning Python. Got tons of resources. His is great. I use it for a different class, and works out well. So lots of resources here, but you've got to put the time in. And if it's not going well, the time to tell me is not 2 weeks before the final project's due, right? The time to tell me is as soon as possible so we can figure out what's going on. We've got a really cool engineering learning center. They got free tutors or no additional charge tutors. It's paid for by your tuition dollars. So like you just don't have to pay more for it. It's funded through the school. They've got tutors out there which are great. A lot of them know Python. I don't think all of the tutors do, but a lot of the tutors will know Python. So we could chat with them and make sure if you need any additional help, they can help you with that. I've got office hours. I didn't come this morning. My apologies. So if you ever look for me during office hours and you don't see me, like shoot me a message. Sometimes I'm out getting coffee or in the bathroom or just running late. Just shoot me a message. Let me know, um, and I'm happy to help. Right? But you've got to come and ask for help because I'm not going to know if you need it. Okay, as we go. All right, so we'll get into a little bit of branching here. Just some basic ones to start. That should be enough to get us going. And then we'll finish out the chapter next week here. So I think we'll have a little bit of extra time today. I don't think we'll go the whole hour 15, which usually works out well. If by the time I've talked for 45 minutes, I get a lot of blank stares. So going a whole hour 15, I get a lot of blank stares. And if you're zoned out, it's not all that helpful for you. So if that happens, let me know. We can always take a break, go get some coffee or something, and come back or get a Coke. Yeah.
So is it always gonna be like this? Like 1 week you do chapter like three, and then it's gonna that chapter is gonna be like the next Monday, and then the next week's gonna be chapter four. And then
Yeah. So each week we'll have the chapter, and then the Zybooks will be due the following Monday, 11:59 p.m. is the plan for that. So um, next a week from Monday, right? So chapters 1, 2, and 3 are due on the 15th here, and then chapter 4 will be due on the 22nd. Chapter 5 will be due on the 29th. Chapter 6 on the 6th. Chapter 7 on the 13th. So that's the plan for your Zybooks reading. Um, I had someone ask me in my earlier class too. They said, "What should I do for notes? How do I take notes?" I was like, "Well, that actually is really hard because I write all the code, I talk about the code, and I post the code. I generally don't recommend you follow along with the code. I type faster than you do, probably, right? And the syntax and tabbing things and getting the colons and spaces things. Like if you're paying attention to replicating what I'm doing, you're probably not listening as well. And ideally, that's the better part of what's happening is explaining what the code is doing here. And then it's all recorded. You can always get the code after the fact. But taking notes in software classes is hard, right? It's all here's some concepts, and I want to show you examples right away. Is that a question?
so what project?
Yeah, I'll talk about Project Zero today, so I'll post it in Canvas for you. We'll have 2 weeks for that, so it'll be due on the 24th before class starts. Because on the 24th, one of the things I'm going to do is go over the solution to the project. Um, I tend to get decent feedback that people seem to think that's worthwhile. It doesn't take me long to do the solution. Sometimes it takes a little bit of time here. But again, I've been doing it for 20 years. So if it takes you a couple hours and it takes me 15 minutes, don't feel bad. Right? There's nothing wrong with that. That's perfectly fine for where we are here. Um, so I'll go over the solution to Project Zero on the 24th, and then we'll talk about the next project as well and finish up anything with loops here. It should be pretty good. So like every other Wednesday, we'll talk about a new project, find the solution to a project. So that like half the Wednesdays will be a little bit shorter. Should work out pretty well here. Functions is a big chapter. Branching is there's a lot going on, and branching we'll spend a lot of time there. Should be a lot of fun. And maybe we get to start loops a little bit early. We'll see how we get there. Schedule's a little bit funky here. So next Monday we'll do our lab on branching here. So we'll have talked about branching a little bit today, most of it on Monday. We'll do a lab on branching following lecture Monday. On the 17th, pick up anything we missed here. I might have a comment or two about the lab. And if we can get started on the next thing early, great. If not, that's okay. And then with the readings, ideally you've at least looked at the readings before I talk about them. That'll help make the things I'm saying make a little bit more sense. If I'm the first time you're hearing it, as you noticed, I talk fast, I drink a lot of coffee here. Holler at me, I'm happy to slow down, but you'll probably get more out of it if you've at least gone through the Zybook just a little bit, right? Looked at some of the concepts here. If you did all of the reading, fantastic, even better here. But again, I get it. The due date's the due date, and most people wait till the due date to do things here. Um, the Xi Labs will take you time. Please don't wait until 10 p.m. to start these on Monday, because it will probably take a good amount of time to get these done here. One person did the labs from chapter 3. if you would like to embarrass yourself and tell everyone how long it took you, you're welcome to, just as a warning for your classmates. How long did that take? Anybody? Uh, Not that? Okay. Like an hour, 2 hours, 30 minutes? An hour? Okay. Cool. Not bad. So not terrible, right? But again, don't leave it for the last second. You'll be sad. All right. Should we get into chapter 4? A little bit of branching? All right. I just want to hit a couple pieces of it here. So I'm going to fire PyCharm here, just enough to get you into Project Zero, and we'll talk about Project Zero. It's our first starter project. It's not going to be very big. It's okay. It's a good practice. Again, the goal with labs is you get them done before you walk out, or I help you with them. Right? I'm happy to help with labs. That's your chance to make sure you can do the things. Right? You've seen me do it. You've done it in Zybooks. You've ideally done some Zylabs. You're, here's an assignment. Go do it. I don't always give tons and tons of directions when it comes to the labs. Like, here's what you go do. You have to figure out some of those steps, but I'm happy to help. With the projects, it's you go accomplish this task, and I give much less help. Right? I'm happy to point you in the right direction, but I'm not going to tell you what code to write. When it comes to the labs, you're like, oh yeah, you have to use this code, right? The projects are much more on your own when it comes to that. So again, Project Zero is sort of a soft start for us here. That it won't be too complex, I promise. But it's a chance. Let's practice that here. They'll get more interesting as we go into project 1, 2, and 3, and then our final project, of course, will be larger. Here, being the bulk of your grade in the class comes from that final project, and we've got a month to work on it here. Um, Again, looking at the schedule here, this last day, my goal is you're done with the final project on the 8th. I would love for that to happen for you. So then you have nothing to worry about for final exam week for this class because it's done. All you have to do is get up and talk about it, which will be a little bit uncomfortable if you don't enjoy public speaking, but that's why we practice it, right? The more you practice things, the better you get at them here. By the time you've done a presentation in almost every class, you'll have done what, like 30 to 40 presentations. You should feel relatively comfortable having practiced it that many times, right? So we want to get you comfortable with that because you want to be able to present your ideas to your team, present your ideas to your company, your organization, whatever it happens to be. Make your pitch. Here's what my software does. Let me talk about it here. Be comfortable with it. It's really fun. And I say it's fun because I like to talk a lot. That's kind of one of the reasons I'm here. I got into teaching. So, all right. I got PyCharm fired up. Let's make a new project. New project. All right. Again, I'm going to put it in my course repository here. So that's the public one that you all have access to, right? Not the lab repository. When you do a lab, you have a lab repository. You'll put it in the lab repository. When you have a project, you'll have a project repository. You'll put it in the project repository, right? Just to help keep things organized. Um, Don't create a Git welcome script or Git repository, but do create your welcome script. Life is good here, so we'll call this one branching. I'll do it in this window. I don't need the other one here. Um, and now we should be able to write some code. Give it a second to think, drink some coffee. These virtual environments are a little bit slow, but they're a good habit to get into, so it's worth the 15 seconds every time or whatever. All right, I'm just going to grab all this and delete it here. I don't need any of the starter stuff here. All right. So far with our code, when we hit run, it goes this line and 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 gets to the end and it's done. Right? It runs every single line of code, which is kind of boring every time we run it because it will do the exact same thing every single time we run it. Right? So what we're able to do with branching is we're able to run different pieces of code based on if something is true or not. Right? So we can say if something is true, run this code. If it's not true, run this code. Or even, you don't even really need that else bit here. We just say, if this is true, this should happen. So we can say something like, how about the temperature? Temperature is a int of an input here. You probably give me temperatures and whole numbers here. What's the temperature? Right? And then we can say, hey, if my temperature, and now I get to use my relational operators, which is our fancy term here. You probably haven't really thought of much used in math class. If it's greater than something, if it's greater than 60, should we do Fahrenheit or should we do Celsius? I'll do Fahrenheit. Okay. The terrible American system here, which is awful. We should switch to Celsius in the metric system, but no one wants to do hard things. It's not even hard. It's ridiculous. Everyone else in the world uses a better system here. but we like to stick to our stupid one. Anyway, so if the temperature is more than 60, then we can do something. We can say, hey, print, you don't need a jacket, or something like that, right? So if the temperature is not more than 60, this line of code doesn't run. And a couple things you might notice here, there's a colon after this, which is weird. This is some Python syntax. So the colon means, hey, I'm about to give you some code here that belongs to this statement, essentially. It makes a code block. Um, so anything that comes after this, if it is indented, will run only if this is true. So Python's fun. It uses white space here or indentation to show that it belongs. So if you try and bring this line back here, it's going to yell at us. We get a red line here, and it says indent expected. It's telling us, hey, you started an if block here, but you didn't put any code inside the block. So oops, that was not what I wanted. Oh, goodness. I need more coffee. Other languages will use things like curly braces to indicate this block of code. Python says, no, we don't need you to type extra things here. Just hang it off there, indent it, right? You use white space, which is a little bit different here, but if you're starting with Python, it's great here. And then maybe we'll say print here, you might want sunscreen. I don't know. We don't know if it's sunny or not here, but at some point you might want sunscreen. And you can have as many lines of code inside this block as you want here. If it's indented, it'll run if this is true and only if it's true. Okay. Now, if we want something to happen, if it's not true, here we can say else or otherwise, right? So if this is true, do this, else do this thing. So you go down one of two paths. You make a branch in your code that either this happens or this happens. Okay, so if it's not more than 60, then maybe we'll print here should have a hoodie. Whatever we want to say here. And then again, you can have as many lines as you want here. Print more advice from dad. Okay. When we're done with our branch here, we come back to our normal level of indentation. So our code starts going line by line by line by line, and then it splits. It goes this way or this way, then it comes back and keeps on running. Right. So we've made a branch, and then we come back to where we were here. Print, have a great Wednesday. Right. So when it runs now, it can do something different based on what the user enters. So it's actually interesting here. And when I run it, different things can happen. So what's the temperature? 55. We should have a hoodie. More advice from dad. Have a great Wednesday. This is going to happen no matter what because it's outside of the branch here. We run it again and say, hey, the temperature, what is it, 75 today or something? You don't need a jacket, might need some sunscreen. Have a great Wednesday. So we create these blocks here that run if something's true or if something's not true. Now, you can have more than one condition here. So this is where it gets to be a little bit interesting. So maybe we'll say, how about your score? So maybe we'll ask for a score. So we'll say score is an int of an input to your score, like 1 to 100 or something, right? So I'm going to like suggest, hey, 1 to 100, because who knows what people are going to enter here, right? And now I can say, hey, if your score is greater than 93, I'm going to print, that's an A. Now, if it's not greater than 93, I want to check, okay, otherwise, is it greater than something else, right? So it would say else if, but the fine folks in Python said that's too much typing. We don't want to have to type out else and then if. So in Python, we say elif. We saved 2 whole characters, yay. But else if here. Else if my score is greater than 90, we print A minus. Elif my score is greater than 87 here, or greater than 86, right? Because an 87 should be a E plus, E plus. Elif my score is greater than 83, we'll print maybe on and on and on. So we've made this chain of if, else if, else if, else if, else if, else if. And what's fun about these is if we chain them together, eventually we can have an else here, print f or something, right? But imagine we've got some more in here. We just don't want to do all of them right now. Um, if I chain them all together here, they are mutually exclusive, meaning only one of these branches can run because they're all part of the same chain. So I'm going to go down one of these paths, this one or this one or this one or this one or this one. One of them I have to go down because I've put them all together here, and I also have a default else. So if it's not one of these where it matches, it must be the else path, the default. Yeah.
So for the first two equal greater than 93, greater than 90, would it print out both? So numbers greater than
No, so because they're mutually exclusive, one and only one of them will run. So it's the first one that it matches. So if it's greater than 93, I get an A, and then it just jumps down to when it's done. So all the way down here prints out, hope you like your score, right? So once it finds one that matches, the rest are ignored in that block. Yep, that's a good question. Yeah,
Tend to go top to bottom.
yeah. So it looks at this one first, and then looks at this one, looks at this one, looks at this one. If it doesn't find one of these that are true in an if, else if, elif, 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 if we have this default, it runs that one. Now you don't have to have a default, but a lot of times that makes sense. That okay, none of these matched. It must be this one here. Um, and notice we don't have to do a lot of work. Like I didn't say, hey, the score is less than 93 and it's greater than 90 because I can't get to this line here if it's not greater than 93. I know not too many knots here, but if it's greater than 93, none of this runs here. So if it's not greater than 93, I'm going to look at, okay, now this one. If it's not greater than 90, now I get to look at this one. If it's not greater than 86, I get to look at this one, right? So because we've chained them together, we don't need to put a lot of extra work in there here. Now you can put all that work in if you want. It's actually less efficient, but it can do the exact same thing. So in Python, we can say, hey, now Python also lets us sandwich our variables, which is fun. Other languages don't let us do this, but I can say 93 is less than, um, or hang on, so the first one's gonna be the same. So score is greater than 93, we'll print an A. But now my next one, I don't have to use an else. I could just have an if. Now here I can sandwich. So I can say 90 is, or 93 is greater than, my score is greater than 90. Actually, this should be equal to then, right? I want to make sure I'm including all the right ones here. So I can have a three variable relation, right? Is it less than this one? And so if you're familiar with math, this makes a lot of sense here. I'm terrible at math and English, and just seems awkward to say, but is it between 93 and 90? Essentially, we're saying, so is it greater than 90, and is it less than or equal to 93? Right? We can write it this way, and we can print a minus. Another way we could do it here is we can use something known as logical operators. Oh, and we've been using logical operators all the time in English. It's and or, right? When you go to McDonald's and they say, "Do you want a burger and fries?" Everybody, of course, says no because McDonald's fries are nasty. They're like garbage fries. There's no flavor at all. It just tastes like salt if you're lucky, and even that is just they're awful. So a burger and fries, automatically no, because you don't want the fries here. But if they say, "Do you want a burger or fries?" You say yes, and they look at you like you're crazy. But you ask me a yes or no question, right? Do you want a burger or fries? Yes. Yes, I want a burger. They're expecting you to say the burger or the fries, but the correct answer to that question is yes, right? But then they're like, "Sir, this is a Wendy's. Please leave." And yeah,
Well, I put on line 26, when you put like single apostrophe, like the A.
the single quotes you can use single or double.
So
Yep, interchangeable. Yep. So I flip back and forth a lot here, but yeah, Python doesn't care as long as you start with one, you end with it, you're happy. So um, whatever you prefer. Um, So with anding, right, both sides have to be true to make the whole thing true. With an or, if either side is true, the whole thing is true, right? Do you want to go out to dinner or do you want to stay in? Yes. Again, that's not really meant to be a yes or no question, but that is a yes or no question, right? Do you want to do this or this? Yes. I want to do one of those things here. Um, so we can use logical operators. I can say 90. I can say score is less than or equal to 93, and score is greater than 90. Right? Now, PyCharm's going to tell me, hey, you could simplify this here, and it wants to give me this. Because Python lets you do this, and it's like, oh, hey, you should do the easy thing. You did more typing than you need to, which, yes, that's true. But, oops, I didn't mean to actually select that. Right? We want it to be the exact same thing here. So print A minus. So we can and things together. So if this and this are true, the whole thing is true here. So just like when we look at anding here, so true and true, the whole thing is true. True and false, the whole thing is false. False and true, the whole thing is false. And false, the whole thing is false. So the only time it's true when we're anding is if both sides are true, right? because this and this both have to be true to make it the whole thing true. When we look at ors here, so true or true, the whole thing is true. Do you want a burger or fries? Yes, if you want either one of them, the whole thing is true. Do you want true or false? Do you want a burger or fries? If you don't want the fries, but you want the burger, the answer is still yes. I think that's still true. A false or true, the whole thing is still true, right? So if either side is true, the only time a or is false is if both sides are false. So we can and things together, or we can or things together. Those are logical operators. We'll spend more time on them next week. Just want to kind of introduce the idea here. And with Python, there's more than one way to do it, right? This way, which is a little bit longer, or the shorter way, whichever way you like is great here. And you can even write it the other direction if you want it, right? We can say, hey, score is greater than 90, which is greater than or equal to, no, less than or equal to 93. Nope, sorry, this way. Score, goodness, sometimes I'm bad at these, A minus, right? This should be the same as this one, right? We just reverse the direction, right? It's still score is less than 90 is the same as score is more than 90, right? Score is less than or equal to 93 is the same as 93 is greater than or equal to score. Yeah.
So if you input it 9, since it's less than, not less than or equal to, what is still fine?
No, so a 90 exactly would not trigger an A minus. We probably should be less than or equal to, shouldn't we? Yeah. So we should fix that for you, right? So yeah, less than or equal to 90. Thank you. Everybody wants to make sure those letter grades are important, right? Sadly, because anytime you measure something, that's what gets to be what people focus on. So if we measure GPA, people are like, oh, the GPA must be really important here. Don't know if there's actually any correlation between GPA and like how well you do. Okay, I want to Google that now. GPA and job performance. Not strong. Is GPA a good predictor of workplace success? Okay, so it might have a correlation, but not a strong correlation. Is that what that is here? Interestingly. A study out of the University of Iowa. Academic performance has weakened as a predictor of graduate performance in job roles. Can be, but not interesting. Think that makes sense, right? School is not work, right? Being good at school or even like getting good grades. Yeah. Okay. Anyway, we don't need to go down that rabbit hole. So I can branch off of different things, right, with my cases here. Now, this is all numeric based, which is interesting, all well and good here. But what if I want to do something like the weather, right? So we'll say the weather isn't just an input of what's the weather like. And again, I'm going to suggest a couple things like sunny, rainy, cloudy. Sure, right? I don't know what they're going to type in, and we haven't got to the chapter where we can actually make them give me one of those choices here. So hopefully they enter sunny or rainy or cloudy because I suggested those here. They might tell me the weather's peachy. Sure, they've got nothing to do with that. So if then they tell me here, now we can say, okay, the temperature is more than 60. Let's go now look. Hey, if the weather now equals, so this double equal sign, right? A single equal sign assigns a value. The double equal sign says, does it match here, right? Because we assign with a single equal sign, so I can't use a single one. So if the weather equals sunny, then you do want sunscreen. Or don't forget, I don't know, don't forget the sunscreen, right? If the weather's not sunny, probably fine without it here, right? So you can put an if inside of an if, right? So whether or not it's sunny, we still don't need a jacket. But if it's sunny, we should remind them not to forget the sunscreen. And then what about if the weather is rainy? Print, bring your umbrella. So if it's sunny, don't forget the sunscreen. If it's rainy, bring your umbrella. If it's cloudy, we don't have to have anything here, right? So we don't have a default case here because and if they typed in peachy, I don't need to tell them anything. If they typed in cloudy, I don't care. It was an option. It was a valid choice here, but we've got nothing to do with that here, right? So you can compare strings by saying, does the string match? Now, let's give it a try here. So what's the temperature? Let's do like 75 and sunny. it didn't tell me to bring the sunscreen. You know why? Because I typed a capital S. Right? Capital S's don't match lowercase s's. It's kind of a bummer. So one thing we can do when we're getting input, you can say, hey, I want it lower. So that will lowercase whatever the user types in, it will convert it to a lowercase input here. So if I'm checking against lowercase, I can lower the input. So it saves me a little bit of hassle here if users give me weird things here. So 75 and sunny, right? I can yell at my computer, tell them it's sunny out, and it converts it to lowercase and will match correctly. So lowercasing input is pretty helpful if we want to be comparing that input to some value here, right? Will save us a little bit of hassle. Okay, so far that seems to work okay. So I can compare numbers with relational operators, right? Is it greater than, less than, equal to? There's also a not equal to sign here. So we'll say none of those are really fun to try and not equal to with here. I'm trying to think of one. I don't know. I don't have one off the top of my head right now. But it is exclamation mark equals is the not equal sign. Okay. Don't worry too much about it. We'll talk more about it next week. Maybe I'll come up with a better example by then. But this should be all we need to be able to be successful with the first project. Some basic ifs here with some comparisons. Okay. We talk about the project. Let me go set up a new repository for you here, a new link. Again, I like one repository per project. Just makes my life easier. No, I don't want that one. Archive. Get rid of that one. 1501. New assignments. CIS 1501, fall 2025, project 0 here. And we'll use my Python template. So it gets you the README file and it gets you the git ignore. It's great. Should not have that main PY file anymore. I think I removed that, right? Ran into issue on Monday. Should be fine. So here's the link for it. Let me come into Canvas, I'll go to assignments, make a new project. Oh, we need a new group here. So this is projects. So for project 0, nope, project 0. So this will be doing 2 weeks, right before class starts. So this one I have to change to 12:30 p.m. Is their picker terrible? 12:30 p.m. So I'll go over the solution in class here for you. We'll call this one 10 points. I'll build out a rubric for you so you can see where the points come from. Please submit the URL of your repository. Add a screenshot of it running to the README. And also include a self-assessment using the rubric in the README. So score yourself, right? Here's where you get the points. Use the rubric. Tell me how many points you got, right? And I'll show you how to do that in a minute here. All right. And then we are going to create a program that helps the user plan a party. Okay. So we're going to ask them a couple things to get information about the party. And then we're going to tell them what they should do, how much it's going to cost, essentially what they should buy. Okay. So first we need to ask the user how many guests are coming to the party. Okay. So how many people are coming to your party? Give me some number. Great. So we know how many people will be at the party. Now remember, you're there too, right? So if I say 4 guests are coming, there's 5 people at the party, right? And you probably want to eat some food, right? Buy food for yourself, right? Don't go hungry. Then we want to ask, what are they serving? Okay, so what things would you typically serve? So we're going to choose 3 different options to serve at our party here. So what's something you might have at a party? What kind of food or drink?
Pizza.
Pizza. All right, so pizza's an option here. What's another thing we might do at a party?
Salad.
I heard salad. Salad, okay. And then what about some sort of beverage? What it was like just a beverage only party? Some sort of pop? Okay, sure. You can call it Pepsi if you want to drink gross stuff here. That's fine. I'll bring my Coke. All right. So we're going to assume that here we're going to do a little bit of arithmetic for them. So if we're serving pizza, assume the average person eats 1/3 of a pizza. Okay. 2 1/3 slices on the average 8-slice pizza. Is that? That didn't work. 2 2/3. I can't do math. It's really sad. 2 2/3, right? Times 3. All right, 8 divided by 3. You guys are looking at me like I'm crazy. 8 divided by 3. 2 2/3. Okay, I got it right the second time. 2 2/3. right? Now, can you go to the pizza store and say, I want 3 1/3 pizzas? No. So when we tell the user you need to order this many pizzas, we have to round up. Okay. There's a way to do that here. This is something I'd like you to go Google. Just, it's okay. It's actually in the Zybooks too, but you can Google this. It's a one-liner. This is your chance to practice good habits of, hey, I had to Google for this. Here's my source for how I rounded up. Okay. So I'm expecting everyone to have a citation for this is how I learned how to round up.
I got something to read me.
Just write in your code. So, yep.
Like
So
that
right in here.
comment.
Yep. So, I found how to lowercase input from http:// something here.
You can say like a Discord source.
Sure.
Just put like
Tell me Discord.
put Discord like what a server name was.
Sure.
Okay.
Yeah. I just want to know it's not yours. Right. That's good habit. This is academia. If it's not yours, you cite your source. I'm not aware of any sort of APA citation format for writing code. If there is one, I don't want to know because that just sounds awful, right? I'm happy with here's a comment right above where I used it. This is not my idea. I got it from someone else, right? That's what we do in academia. So we're going to practice that this first time, okay? It's really easy, I promise. It's in the math library. I think we even looked at it probably already, but we probably forgot about it since then. I think it was in chapter 2. Maybe not. Maybe it wasn't chapter 2. Anyway, not too big of a deal. So make sure to round up when we calculate how many pizzas we need to buy, right? Can't buy half a pizza here. Now, we're also then going to ask them for the cost per pizza, and calculate expected cost. So we're going to tell them, hey, you need to buy this many pizzas. It will cost you this much money. Right? We're planning for a party. Hey, if you want to invite 30 of your friends, you're gonna spend a bunch of money on pizza. Right? If you want to invite 5 friends, you'll spend less money on pizza. Right? That makes sense? Right? So for salads, if we're serving salad, assume the average person eats. Wow. Eaches. How did I, you have to tell me how to do dumb things here. Eats. How much of a salad? Now we're talking probably like big salads, right? So like maybe you eat a fourth of a salad. One salad will serve 4 people. I mean, if we only have salad at the party, though, maybe they eat more. It's the number doesn't actually matter. That's okay, right? Um, so same idea. Round up, and calculate how many salads to buy. Ask the cost per salad, and calculate the expected cost. Right? You get the idea here. So same steps here, slightly different arithmetic. Calculate the. Thank you. You get a bonus point for pointing out when I'm done. Sadly, points don't matter though. All right, and then if we're serving pop, assume the average person drinks, I don't know what, 0.75 liters here. If you buy 2 liters, probably drink more than 1 cup, maybe not 2 big ones. I don't know. I'm just making it up here. Liters of pop. Round up and calculate how many 2 liters to buy. If you want to go cheap, you can buy the Kroger brand for the 3 liters. Do they still sell those? Like the big K 3 liters? Man, those were so good as a kid. Definitely, definitely lower quality than the name brands here. How many 2 liters to buy? Ask the cost per 2 liter and calculate the expected cost. If they didn't enter a valid choice, tell them to please try again later. So we haven't got to how we can keep the program running. We'll just say, please try again later. Program finishes. They can hit the run button again because they didn't give us what we expected. Okay.
You got multiple spelling errors in that third to last sentence.
This one?
What
Okay.
about that?
Calculate.
Yeah.
Assume. Thank you. Usually it spell checks me. That's really weird. I don't know why it's failing my spell check now.
Probably you tried to fix it, but I think it's still wrong.
Calculate. Oh my goodness. All right. Thank you. Miss my spell check. Usually this like spell checks me. Canvas is failing me right now. All right. So let me save this one here. Now I can add the rubric. Okay. So we'll get this is project 0. Um, I'm okay with partial points here. If you tried to do it but didn't do it right, feel free to give yourself a partial point here. At least you tried. So this is asks for many guests and includes the host. Right. So how many people are coming to the party and adds you. You're someone there who's eating, right? And then then uh, you want, oh my goodness, why am I blanking here? So this is calculates uh, number of pizzas and cost correctly. You get 2 points if you do the pizzas right. Calculates number of salads and cost correctly. Calculates number of 2 liters and cost correctly. And if an invalid choice is given, tell them to try again later. Okay, this is not a complex project. Again, sort of a soft start here, but giving you some directions, but not telling you exactly what to write in Python code. Right? I'll get you pointed in the right direction here as we go. But I think just even after the quick lecture on branches today, you've got an idea of how to do this. Right? That's sort of the goal here, and that's okay. This can look different for everybody. Right? Not everyone will write the same identical code. That's okay, and you're welcome to talk about it in English. Talk about it all you want in English. Right? Perfectly fine to collaborate there. We're not sharing Python code though, right? Is that okay? You don't need to ask the chatbot how to do this. I promise you. This is not that hard. You're about 36 hours into the course by the end of this week here. You should be able to do this without the chatbot having to help you, right? If you run into problems, let me know. Again, try for a good half hour to an hour to get yourself unstuck, find yourself a solution, and then reach out. Happy to help. Um, this should go relatively quickly here. Sort of a soft start here with our first projects here. It's only 10 points. Later projects will be worth more points. So 10 points now, the next one will be 15, the next one will be 20, the one after that will be 25, is what I typically do with projects, right? Because we don't get to forget anything that we've done. Right? The work just builds on itself here. We're going to keep using all of our types, and we're going to use our branches from here on out. We never get to forget those, just like a math class. Okay? Um, Make sense? I think we did enough from chapter 4. Again, we'll get into the rest of chapter 4 next week here. Should go relatively well. We'll get through most of it on Monday here and be able to do a lab on branching here. Um, get some practice in, get the iBooks in. Now remember, chapters 1, 2, and 3 are due Monday, 11:59 p.m. It doesn't take super long, but it does take some time. And we've not had very much participation. I think one of you got through chapter 3. Good job to the one of you. Um, Ideally, you're reading ahead, and you've read it from the iBooks before we've talked about it in class. I get it. Life is busy. Deadlines are what they are here. I'm not going to require you have done it first because that just seems cruel and unusual. I'll wait till after. All right. Okay, so far we got about half an hour extra. You can actually get started on that if you want here, and go from there. All right, I'll see you folks on Monday then. Thanks so much.